Good evening, everyone. Am I audible?
Yes, yes,
Thank you.
yes.
So, this is the last week of the course, and this is, I think, last month of the course, and this is week 9. So, for now, we have talked about all the primary treatment as well as secondary treatment, and we have also talked about the slush treatment. So, these types of treatment were conventional, means we have been doing this for years. Now, just to increase the reusability of the water or the sludge, we want to go for some secondary treatment. So, what is this secondary treatment? So, this is the excess treatment that we do to improve the reusability. For example, if we want to make our water as a palatable source, means a drinkable source, so our wastewater, then we will go for a higher quality of treatment. Depending upon the end use, we treat the water. So in tertiary treatment, we try to remove all the emerging contaminants. Emerging contaminants means various medicines as well as various personal care products, cream powder we use. So these things will go inside water and they remain there. Our conventional treatment plants, what I mean, our all those primary and secondary treatment plants are unable to remove all those problems, all those pollutants. So some tertiary treatment is required to remove all those. Apart from that, we have lots of nutrients in our water, so we don't, if we are releasing water enriched with nutrients into the water body, you will see some algae formation. There will be excessive plant growth, which may reduce the oxygen content of the river or any water body. That's why we want to remove these nutrients as well. So these special things, special treatment technologies comes under tertiary treatment. So in this week, we are talking about tertiary treatment. I hope you have gone through the lectures. So I'll share my slides, we'll solve some questions, and you can answer them in the polls. I'll share my slides. So as I have told you, this is week 6. So I'll be launching polls, and you can find them in activities tab at the right bottom corner of your screen. So I hope you can see the polls for question number 1, and this is question number 1. The major target contaminant during tertiary treatment of wastewater are, we are talking about major treatment, major tertiary pollutants. When we treat any tertiary treatments, oil, grease particles, pathogens, metal nutrients, oh, you, metal nutrients and resistant microbes, suspended particles and pathogens, or none of the above. Okay, we'll see the answer. So answer is B, metal nutrients and resistance microorganisms. See, pathogens are also microorganisms, but pathogens are disease causing microorganisms. Okay, microorganisms may be many, but disease causing microorganisms are few. We call them pathogens. So, even in primary, secondary, any conventional treatment technology, we do disinfection. By disinfection, we try to remove these pathogens, but we do not take care of resistant microorganisms. Resistant microorganisms may involve those microorganisms which are resistant to drugs now. Like if you are ill, if you have some fever, so you will take some medicine. Okay, so only 100 milligrams of medicine will work. But with time, you will increase the dose of medicine if you are having the same kind of fever, because the microorganisms inside your body are now, there will be no change in them with that doses of medicine. So we increase the dose. So that is all due to this resistant microbes. Okay. So metal nutrients resistant microbes are treated and in tertiary treatment. So this is question number 2, and I'll launch poll for question number 2. Match the following tertiary treatment approaches with the treatment unit. Physical, biological, and chemical, we need to match them. Lime, membrane, or Anamox process. Which is which? This is 1, 2, and 1, 2, 3, and this is A, B, and C. Okay, we'll see the answer then. So the answer is B. Yes, you were right. Answer is B. Membrane separation. Uh, in lime precipitate. First of all, let's talk about physical approach. So physical approach, we are saying membrane separation. There will be a one membrane, a cloth-like structure will be there. So it's like a sieving action. Means there will be small pores. Water may pass through these pores, but the bigger particle won't be able to pass. So this is just a physical treatment. So membrane treatment. Uh, so one is related to B. Now biological treatment. So Anamox bacteria, they are kind of bacteria. These are bacteria which help in the removal of nitrogen containing compounds from the water body. So these are Anamox bacteria. Anamox means this is a full form made of anaerobic ammonium oxidation. Okay, so anaerobic ammonium oxidation. And the other is chemical approach. So we will add lime to precipitate various things. Even for the removal of hardness, we use lime. This is question number 3, and these are polls for question number 3. Which of the following is a pressure-driven membrane operation? Means if there is a membrane, it is mostly physical operation. Now it is saying pressure-driven. Means we apply some pressure to transfer the water or the ions or any pollutant from one side to another. A pressure will be applied in one area, one side, so other side the pollutant or the water may accumulate depending upon the type of membrane. Okay, we'll see the answer. So the answer is A, reverse osmosis. What is electrodialysis? Electrodialysis is concentration driven, as well as some electrical current will be there that will cause some potential difference. Membrane distillation and dialysis, concentration driven. This is question number 4, and the polls for question number 4. Which of the following is a probable disadvantage of chemical approach for phosphorus removal? We are talking about disadvantage. Mostly we use a chemical approach for phosphorus removal. So what is the major disadvantage of this? High sludge volume production, costly operation, additional treatment, or all of the above? Yes. So you are right. All of the above. And this method is mostly used, okay, because other method is quite complicated. Other method means the involving of microorganisms. It's quite complicated. So there will be great deal of study involved to do that. Even the research is still going on in this area. So this is question number 5. Polls for question number 5 are live now. Which of the following statement about the conventional nitrogen removal process is true? We are talking about nitrogen removal. Nitrification, denitrification is the biological method of nitrogen removal. Small volume of oxygen is required for ammonia oxidation during for nitrification, denitrification. Denitrification is accomplished by facultative heterotrophic bacteria. All the statements are true. Second, third, or first or third. Try to answer this question. It's a very important question.
It's two and three. Yes. Answer is
Okay, we'll see. So the answer is D. Yes, both of you are right. What happens in nitrification, denitrification? In nitrification, uh, see, this process is the nitrification, denitrification is a process of aerobic and anaerobic process. In nitrification, aerobic condition will be given. So all the organic nitrogen is converted to nitrite, then to nitrate. And in denitrification, anaerobic condition is there. So what happens? The nitrate is converted to either in some reduced state ammonia as well as nitrogen gas. So nitrogen gas, we want to convert it into nitrogen gas. That is better form. So and anaerobic facultative bacteria are, they can sustain in an aerobic as well as anaerobic condition. As I have told you, denitrification is favored in anaerobic condition. So facultative bacteria work, which may survive aerobic condition also, but they are mostly anaerobic. Okay. So this is question number 6 now, and these are the polls for question number 6. The first step of adsorption mechanism majorly involves the process of, what is adsorption? There will be a bulk phase, probably a liquid. This will be an adsorbent on which we want to, there will be small pores. All what we want, all the contaminants that we are targeting, we want them to stick on these pores so that when we take out this adsorbent, all the pollutants come out with it. So what we are basically doing, we are changing the phase on which a contaminant is there. We are changing it from liquid phase to solid phase. So this is adsorption. So the question is, the first step of adsorption mechanism is mass transfer, diffusion, pore surface adsorption, and all of the above. So the answer is A. We are talking about the first step. Okay. These all are the steps. These are all the steps. But we are talking about first step. I hope what mistake you have done in this question. So first step is mass transfer. This is adsorbent. This is an adsorption site on which something can be adsorbed. So first, what will happen? The particle from bulk phase will move from here to here. So this is first step, mass transfer. Second step is, now particle is here. It will try to, uh, there will be film of liquid. So it will try to break through the film. So this will be the second step. Third step will be the movement of this particle inside the pores. This will be third step. Okay, so this is how adsorption works. So first step is this, bulk transfer. So this is first step. I hope you got this. Next question is, this is a reaction and we want to know what is this reaction representing? Phosphate removal, nitrification, denitrification or anammox? Try to answer this question. This reaction is very important. Okay, since both of you have answered, we'll see the solution. Answer is D, anammox reaction. So, this is anammox reaction. What is denitrification reaction? Denitrification is the conversion to this, nitrate conversion to this. Okay, some alkalinity will increase. So this is the kind of reaction, basic reaction that will happen in denitrification. Nitrate is converted to a nitrogen gas or molecular nitrogen. Okay, this is anammox reaction. In anammox reaction, what will happen? Ammonium ion will be there as well as nitrite ion will be there. We want to convert them into molecular nitrogen. So this reaction is specifically for anammox reaction. Anammox bacteria will do this reaction. So this is question number 8 and these are the polls for question number 8. Which of the following factors do not affect the ion exchange process? Do not affect ion exchange process. Ion exchange process is similar to the oxidation adsorption process, but what will happen? Same thing will be there, a bulk phase and the pore, but what the change is, something will come in and other thing will go out. For example, A is coming in and B, which was already there, B is going out. So this is ion exchange. Temperature, pH, relative atmospheric humidity and competitive solutes and ions. We'll see the answer. Answer is C. Both of you are right. Relative atmospheric humidity. Temperature, pH, coexisting solutes and ion influence the ion exchange process, but relative atmospheric humidity does not impact the process. Okay, these things are anyway happening inside the bulk phase, inside the water body. So whatever is happening in the environment outside that reactor, that's not going to change anything. And this temperature, we are talking about the water body. If this reaction is happening inside this jar, then all the properties which are inside the jar will affect. It won't affect from, there won't be any effect from the outside. Okay, so this is question number 9 and these are the polls for question number 9. Which of these is not used for disinfection of treated wastewater? Microfiltration, sodium hypochlorite, chlorine gas or UV radiation? We are talking about treated wastewater. So which is not used for treated wastewater? Others, please answer. So, yes, all of you are correct. Answer is microfiltration. Other process releases the chloride ion, and chloride ion is a good disinfectant. And UV radiation also releases some ions, some oxidized ions, that will help in the removal of pathogens. This will kill any pathogens that comes in their way. Microfiltration, it's just a screening mechanism. There will be a cloth kind of thing. There will be various pores. So some particle will go out, some particle will go out, some particle will remain this side of the sheet. But there will be no disinfection. Anyway, virus, bacteria are very small. They will pass. They will be there in the treated water. So no disinfection is happening in case of microfiltration. Which pre-treatment process may be used to control fouling of membranes? Filtration, chlorination, UV radiation, or all of the above? We are talking about fouling of membranes. We use membranes for tertiary treatment. Tertiary treatment means we use it for the removal of nitrate, sulfate, these things. So what pre-treatment we do? What type of treatment we do for our water so that fouling means the accumulation of uh, dirty particles or dirt on our membrane. To remove that, what pre-treatment we want? Answer is D. Okay, you both of you have answered filtration. That is there. If we will do the filtration, clogging potential will decrease. But there are bacteria, virus, these are very small, okay? So they will pass through the membrane filter. They will pass through the filtration process. So they are there in the treated water. What happens? These small bacteria, virus, not virus, especially bacteria, fungi, algae, what they will do in their life cycle. I hope you have studied this growth curve of microorganisms. Something like this, microorganisms grow. This is number of microorganisms or this is time. So what happens? After some time of growth, after some times of growth, this is lag phase, this is log phase, this is stationary, and this is death phase. So what happens in this stationary and death phase? They will release some particles, some EPS we call them, means extracellular, I'll write it, extracellular polymeric substances. So mostly during stationary and death phase, they release these kinds of substances. And these substances are like jelly. So this will, if the bacteria and fungi, algae, they are coming inside the water. So they will form a gel-like structure on this sheet, on our membranes. And this can also call fouling. So fouling can be basically of these types. I'll show you. So fouling is basically of these types. See, just imagine this is your pore, membrane pore. Fouling can be a bigger particle will clog the pore like this. This is a particle. And this was a pure pore. Other condition can be smaller particle may sit like this. So this will make the pore small. This is one category of fouling. And the third category, which happens due to microorganisms, is the formation of gel layer. A gel layer will be formed which will block this pore. So this is also a kind of fouling. And this is due to EPS. That is why when we do chlorination or UV radiation, we can kill these microorganisms. So this EPS problem can be reduced. I hope you got this. So filtration is not the answer. Answer is all of the above. These kinds of treatment we want to do so that we can reduce all these types of fouling. This fouling can be taken care by filtration. And this fouling can be taken care by small filtration, small pore filtration. Okay, better quality of filtration, or we can say microfiltration. And this EPS, this can be taken care by chlorination or any disinfection. UV, chlorine, ozone, hypochlorite, anything is fine. Moving towards next question. Complete mineralization of organic pollutant or transformation into harmless form can be achieved through. What are these harmless forms? We want to convert all these pollutants into CO2, N2, H2O. We want to convert all these organic compounds into these forms. So how this can be achieved? Co-precipitation, adsorption, advanced oxidation, or sand filtration. Try to answer this question. Okay. So both of you are wrong. Answer is advanced oxidation. What happens in adsorption and ion exchange? I just told you. What happened? A particle will come and stick here, and some particle may go out. So what is happening? Nothing is happening. The particle is just changing the phases. Particle organic matter is not converted to these compounds. Co-precipitation, what will happen? Particle will settle down. Okay. Only in the advanced oxidation process we go for complete oxidation. Complete oxidation, all the particles will be converted to these harmless substances. And there are many more harmless substances. The particle will be, or your pollutant will be converted to that. Sand filtration, you know, it will do nothing. It will just, it's kind of sieve mechanism. Bigger particle will stay and the smaller particle will pass. Okay, I hope you got this. Next is numerical question. Take out your calculators. It will be better for you if you are solving. A 200 liter of wastewater sample containing lead was treated with 2 gram per liter of activated carbon, which resulted in the removal of 90% of the contaminant after 3 years. Volume, okay, volume 200 liters. Activated carbon, how much we used? 2 grams per liter. Efficiency, how we got? 90%. Time, how much it took? 3 hours. First of all, we need to find out the original concentration. After treatment, concentration is 0.5 milligram per liter. This is E, concentration is effluent. We want to find concentration in influent. Okay, so this question can be done by, now for this question there are no polls, you can answer in the chat box. You can try this question. Try this question and answer it. What is efficiency? CI minus Ce divided by Ci into 100. I hope you can do this question now. Try to solve this. Give me the answer. Okay, we'll see the solution then. So the answer is B. Yes, you were right. Same process they have followed. Ci minus Ce upon Ci. Ci we want to know. Ci upon Ci, 1 minus Ce upon Ci is equal to 90 by 100. 1 minus 0.9 is equal to Ce upon Ci. 0.1 is equal to, what is Ce? 0.5. We want to know Ci. So Ci is equal to 5 mg per liter. Okay. This same thing is written here. You can follow any of the methods. Same thing is written, just the writing language is different. I'll erase it so that you can understand. Okay. We'll see next question now. Question number 13. In the previous question, determine the quantity of activated carbon required. So what was total volume of water is 200 liters and the activated carbon required is 2 gram per liter. So what is the total activated carbon required? Correct. Answer is A. Very simple.
Ma'am, I want doubt here.
Yeah.
In the in your the remaining 0.5 milligram, is that to be allowed as because when you see the question, can you just go to the question?
Yeah.
After treatment, the final concentration is 0.5 milligram per liter.
Yeah.
This lead is still in the water
Yeah.
to an allowable limit,
Correct.
right? So if at all we are asked same question in the exam, so it's just 200 into 2, 200 liters into 2 gram per liter. Is that would be that the correct answer?
I'm not getting your question.
Uh, since we are the final concentration is 0.5 milligram per liter,
Yeah.
so it means that some amount of lead remains in the water.
Yeah, true.
Right? So now the question was how much uh, activated carbon we require
Yeah.
to treat 200 liters.
Yeah.
So from this, it is 200 into 2 is right. I mean, as you say, is right.
Yeah.
But the lead which is remaining is some amount of lead is remaining in the water, which is untreated.
Yeah, true.
So do we take that into consideration or we just leave that out?
No. When we are talking about the amount of activated carbon required, this is
Mhm.
based upon the initial volume.
Okay. Okay.
It is the initial volume in which we have to see. So
Okay.
200 into 2 will be there. If this question, it can be 0.1 also,
Okay.
then this efficiency will change. And then
Okay.
this solution of this question number 1 will change.
Okay.
Okay,
So,
initial.
so we have to just solve for the present efficiency of 90% removal.
Yeah.
Thank you. Thank you.
Okay. In this question can be asked like that in that final concentration after treatment is around is your effluent standard. For this question, then you have to check the manual. What is the allowable standard for lead? Then you will know the amount of lead. Then you have to find out the efficiency. This question can be made like that also.
Okay.
But just to make it simple, we have done like this.
Okay.
We
Thank you.
have given all the values.
Thank you.
Yeah. Okay. So now we'll see question number 14. If a membrane, this question is related to the membrane. If a membrane fed with a 750 milligram per liter of TDS generates 60% permeate. Permeate is treated water. Just imagine this is a membrane. This is the flow going XY membrane. This is flow going concentration in. Something will be treated and something will be thrown out as waste. So in treated, concentrated treated, concentrated flow treated, and something is waste, so concentration in waste and flow in waste. Whenever we talk about membrane question, we have to make it like this. So here we have C in is equal to 750 milligrams per liter, generate 60% of the permeate. Okay, 60% of the permeate means permeate is treated water, means QT is 60% of Q in. Okay, and CT is given as 50 milligram per liter. What should be the TDS concentration in the reject, means in waste? We will write as R so that you can understand easily. So question is, what is the CR? Very simple question. Just the dilution question. Can you do this? Please try. The concept is we have to solve for this junction. Q in, C in is equal to CT QT plus CR QR. So this is the equation of continuity. Means the amount of flow coming in should be equal to the amount of flow going out. Okay. So when you will solve this, you will get the solution. Everything is there. C in we have. C in we have. Everything we have, and we have to just solve. We will see the solution. I'll clear the screen so that you can understand it. See for yourself if you can understand this. Okay, we'll move forward then. So your answer was right. It was 1800 milligrams per liter. So question number 15 is a wastewater effluent having TDS of wastewater effluent. Okay, effluent means clear water, treated water. TDS is 2000 milligram per liter and TSS is 15 milligrams per liter. Now it has is treated using ultrafiltration. So this is from that secondary effluent, and this is we are doing ultrafiltration. Means we are increasing the quality of water by doing some tertiary treatment. So 95% permeate is there, means treated water is there. Now 5% goes to concentrate. Same question like last time. Okay, and the TSS is reduced to 0 and TDS is reduced to 400 milligrams per liter. So the total solids removal efficiency is, this is very interesting question. You try to solve this question and we'll see the solution. We'll see the solution now. So the total solids initially what we have, 2050 milligrams per liter. Total solids after ultrafiltration, 400 milligrams per liter. So solids removal is this, and so removal efficiency is, as you can see. As I told you, what is efficiency? Initial minus final upon initial into 100. So we are talking about in terms of total solids. Okay. So total solids is dissolved solids. Total solids is total dissolved solids plus total suspended solids. When we filter our sample, this is filter paper, just imagine, and this is the bucket in which we collect the filtrate. So whatever we have when we are pouring water, whatever we are having inside, we have total dissolved solids, and whatever we have above this filter paper is total suspended solids. So overall is total solids. Okay. So this was the question, guys. I hope you got it. Any doubts?
One doubt, ma'am.
Yeah.
In one of the questions you had asked about what are the methods for reducing the choking of the filter
Yeah. Huh.
membrane.
Yeah.
So one of the methods was filter, chlorination, and UV radiation,
Yeah.
and so on. It means that the filter being used would be of a bigger, larger pore size than the
See,
membrane.
what happens? It depends upon the rate. There are various types of filtration. Like RO is having least size, but see, I'll tell you. Nanofiltration we have, microfiltration we have, ultrafiltration we have, and reverse osmosis we have. See, it depends upon the size. Microfiltration will be here and nano will be here. See, whenever we go for reduced size, cost increases. That is one thing. Okay, so this one is the costliest. Microfiltration is easiest, like it's not that costly. Second thing is, whenever we use filter of smaller pore size, we need to apply more energy for the water to pass. This is second thing. It means smaller pore size filter we will use more energy. Means RO we are using more energy, more electricity, more mechanical force we are using. Third thing, what happens? The amount of reject. As you have seen earlier, we used to have carbon filtration in our homes. Normal basic aquaguard when aquaguard was started. There was no wastage of water or very less wastage of water. Now we have RO. So whenever we open taps to fill water, some water will go out. Okay?
Mm. Yes, ma'am.
So, wastage of water is more. That is why we try to choose a filter in which we can balance out these things. So it's every time when if we go for RO filtration, the choking will increase. Okay, and if we go for this microfiltration of large pore size, something will pass that we don't want. So what do we do? We choose a basic size and we try to pre-treat it so that the cost can be balanced. That is how we choose the filter size.
Thank you, ma'am. Thank you.
Anything else? So shall we close the session? Thank you. Okay, we'll close the session now. Bye bye. Have a nice day. Thank you.